In this video, we will learn how to find out the marginal rate of technical substitution from the given production function when the two factors are scaled up by a factor, let us say lambda. The question is given the production function, output is a function of capital and labor, which is equal to k raised power of 1 upon 3 times L raised power 2 upon 3. What will be the marginal rate of technical substitution between labor and capital if two factors of production are scaled up by a factor lambda? Options are being given. We are supposed to find out the correct option. Okay, so we are being given this production function. Okay, so let's first find out the marginal rate of technical substitution between labor and capital, and we know it is a ratio of the marginal product of labor upon marginal product of capital. Okay, so marginal product of labor is simply the change in the output due to the change in the units of labor employed, and marginal product of capital is the change in the output due to the change in the units of capital units employed. Okay, MPL means the partial derivative of production function with respect to labor. MPK means the partial derivative of production function with respect to capital. Okay, so let's take the derivatives. dq upon dl means we differentiate partially this with respect to L. So exponent of L becomes coefficient, so we have 2 upon 3. Okay, k raised power 1 upon 3 will remain same because we are taking partial with respect to L, and exponent of L gets subtracted by 1, so 2 upon 3 minus 1 is minus 1 upon 3. But by power function rule, you know it symmetrically. Del q upon del k means the partial derivative with respect to k, so exponent of k becomes coefficient and exponent is subtracted by 1, so it becomes minus 2 upon 3, and L raised power 2 upon 3 will remain same because we are taking partials with respect to k this time. Okay, that implies marginal rate of technical substitution between labor and capital is equal to, so let us simplify it, 2 upon 3 into transpose it, it becomes 3 upon 1. Transpose this k here, it gets added with this, so we get k raised power 1 upon 3 times k raised power 2 upon 3. Okay, exponent sign changes when we transpose it from denominator to numerator. Okay, likewise we have L raised power 2 upon 3 here, transpose it here, it gets multiplied, but its exponent sign changes from negative to positive, so it becomes positive 1 upon 3. So 3 gets cancelled, we are left with 2. Bases are same, we can add up the exponent, so 1 upon 3 plus 2 upon 3 is 1, so we get 2k. Likewise here, bases are same, we can add up the exponents, and sum of the exponents again 1, so we get only L. This is our marginal rate of technical substitution. Now you can see our, if I write it like this, our marginal rate of technical substitution between labor and capital is a function of labor and capital, which came out to be 2k upon L. Let us increase both factors by lambda or scale them up by lambda. That means our new marginal rate of technical substitution between labor and capital, when we increase labor by lambda and capital by lambda, so what will we get? So plug here, so we have 2 times lambda L in place of, in place of k we have lambda k, and in place of L we are scaling up both labor and capital here, so lambda L. So this gets cancelled, again we are left with 2k upon L. That means this will be our marginal rate of technical substitution if we scale up both the factors by by a factor lambda. Okay, so the correct option should be C option in this case. I hope I make myself clear and you find out these videos helpful. Okay, please share and give your valuable feedback. I am making these videos for free. I don't charge anything for these except your time. Okay, thank you.